Welcome to my procedural approach for creating the sound of a motorized fan in Puredata. This is something I made one day for a bit of fun. I was recording some sound effects, needed to do a bit of denoising, and I dragged the file into Isotope RX when I noticed that there were some prominent elements in the sound file, and I'll just play a bit of that for you for context. So when I saw the waveform, I thought that it would be a great candidate for synthesizing. I started by defining the primary components, first the switch clicks over here and here, the clear harmonics, and the strong fundamental centered around 500 Hz, and then some pink noise, which has a very steep high frequency roll-off. I approximated this inside of Puredata, starting with the switch sound, which was simply just the switch extracted from the source file and played back. I did this because synthesis wasn't giving me the results that I was looking for. The noisy component is just a noise oscillator going through some bandpass centered around 500, and then some low-pass filtering to attenuate the high frequency. For the pitched components, I'm using a sine sum message to create an additive waveform, which approximates the harmonic relationship of the source file. So we have here the value 1, and that's just to say that this amplitude goes from 0 to 1, and the rest of the values are the relationships. So it sort of emulates what's happening in this waveform over here. This is all tied together by a low-pass object, which creates a nonlinear curve. This reads into a snapshot, which creates a control signal, which is read into this. This controls the amplitude of each of the elements, and then the other two outputs are to control the center frequency for the bandpass of the noise, and finally the pitch of the oscillator. In order to make this procedural, I've exposed a few parameters to the heavy compiler. The first is the toggle switch, so that I can turn the patch on and off. That obviously triggers the switch sound as well. And the operation speed. I have two more components, the fan gain and the motor gain. This is just the noise and the pitched elements, so you can control the levels of them independently. You could expose whatever parameters you want. These are quite arbitrary. So the benefits for using the system is that it's obviously less extraneous noise. In fact, there's no noise. You're only left with the signal that you want, and once you put it through some spatialization or reverb in a game engine, it should sound even more believable. And obviously it's more controllable, so this could be important in a game where, for example, it was an interactive setting and you needed to control the fan for some gameplay elements. Perhaps you're blowing something away and need to control the fan intensity. So using the patch in this way will offer a much more dynamic and interactive experience. Anyway, that's my procedural fan. I hope that you found it interesting, and if you have any questions, feel free to leave them in the comments below.